The first story, the first scenario is a part development process without ICME. You know that the process is driving the part and the material performance, but nobody was aware in this company. So it's a kind of Houston, we have a problem story. The part is failing at the first trial at the end of the design process, and it's just the beginning of the nightmare. There is a task force which is created. Generally, the CEO is at the table and the solution must be found. There is a strong pressure on the shoulders of all the people in the room. And it's generally the case where people doing technical support must find a solution, but without changing anything. Because the cost of change at this stage is really huge. Listening to the designers, the reason of failure is to be found in the manufacturing. Listening to the manufacturers, the design is suspected to be wrong. It's a typical bad silo situation. Finally, a solution is chosen. It's to increase the fiber content in the part, because based on material datasheet, more fibers means more strength. It's so simple and efficient. So let's go. We have found a solution. So during this, the part may fulfill the specs by chance, or it may not. So the decision here is taken considering legacy experience and sometimes heritage from metal engineering. So the first lesson learned here is that decisions taken under pressure and without the good rationale often linked to many prototype iteration. And I remember some customers coming to see us and asking, we need your support, but please don't change the part design and don't change the mold neither, the injection molding machine size. And if you can keep the same material, it's even better. That was typically the case that I'm talking about here. The scenario 2 is the same development process, but this time with ICME. There's no surprise, the scenario will be much better. The process engineer and the design engineers are working together. ICME is the link between the process and the design teams. And during this process, it is found that the direction of stress is perpendicular to the direction of fibers. This is leading to the part to fail. And in